So, hi everyone. This is a preliminary report. So it's an experiment that we've been doing for the past, 8 months or something in a department within Banco BP, software development department. And this is just to share our findings. So I guess that everyone wants to move faster and be more predictable, right? To do more stuff, more fun stuff, and faster is good. So I'll just give a bit of context so that you understand how we started to move fast and in which context. So I work at BPI, which is a bank. It's not a startup. And I help to manage a department within the bigger software department at BPI. So I helped manage 10 Scrum teams, which amounts to around between 60 and 65 people. And we are responsible for the document management systems and all the systems that help to sell credit for people like you, not corporations. So mortgages, auto loans, personal credit, credit cards, all that stuff. And also we have all the BPM stuff for the back office. Okay, so and a few concepts, I'm sure that most of you know about them, but just be sure that we are on the same page. So cycle time, what is cycle time? It's the number of days that it took from starting to work on an item until it was pushed in production. In our case, this means that we start with analyzing a feature and digging up the requirements and all that stuff. Then we do the development, we write code, we do the acceptance testing with our users and a bit more stuff, and then we push it into production, okay? The work in progress age is basically the number of days that passed between starting the working on the work item until the current day, okay? But it means that we still haven't finished the work. And then work in progress, it's probably the simplest one. It's the number of work items that we have on any given day, okay, that are started but not finished. So let's move on. How did we try to move fast and be predictable? We basically decided to believe in Litt's law and in the magic of flow. And it's basically, it's pretty magical, really. So what is the Little's law? What does it say? It's a mathematical proven law that says that the average cycle time equals the average work in progress divided by the average throughput. And well, we want to move faster, so we want to bring this down, cycle time, and we could just say, let's move faster, let's do it. But this is just not a battle of wills. We want to move fast and then it just happens. But this very simple, very easy to understand law has something that's really, really important. We can manage this one. We can manage work in progress. The other ones, well, they are a bit beyond us. We cannot just will to do a shorter cycle time or to increase throughput. But this one we actually can manage. And so that's what we decided to do. Let's manage work in progress. We've been doing Scrum for a number of years, so we already do all that iterative stuff and building small features, not big projects, all that stuff, and that makes this simpler, okay? But we decided to manage this one. And this graph, basically each data point represents the WIP in a given day. So this is back in 2018, and this is basically today, okay? And we started the experiment around here in February, okay? And we can see that before our WIP was just up and down, up and down, up and down. It's pretty obvious that we weren't managing WIP, we weren't limiting WIP. And after, it's basically flat, okay? So we really started managing, and it was all by us. We didn't need anyone else. Okay, so you can also do this. This is a very, very powerful chart. It's called the Aging Work in Progress chart. And what does it give us? Each column, it's a state. So our work items, a new feature, for instance, starts with analysis, then we do the development, then we wait for the acceptance tests, then our users confirm that we've done everything and everything is absolutely perfect, obviously. Then they say that it's done, and the last state is not shown because we've pushed into production. Each data point is one or more work items, and they basically, as they age, they just move higher and higher. So the oldest one in this chart, the oldest work item, it's this one, which is still theoretically at least, it's still in development. And this is how it was before we started the experiment. Whoops. And this is today. And you can see that we basically, all those dead things up here, they disappeared. We did this cleanup, and we are trying to keep things down here. And this chart is really important, and it's really powerful because it gives us almost all the information that we need to manage WIP and to have full visibility of our work in progress. So what happened? In our cycle time, again, we started in February, and there was this going up because we did all that cleanup that I showed on the previous slide. So it went up first, and we knew that it would go up. But then it went down, and it's currently the best since January 2017. Okay, and it represents a 26% improvement of cycle time. Okay, so just by managing WIP, just by following that very simple law, we managed this. We didn't change, well, we did lots of change, obviously, we are constantly changing, but the change that we did, that we can clearly see that made a difference in cycle time, so delivering faster, was using Little's law and believing in it. Regarding delivery on time, so do we fulfill the deadlines? Well, we also did a bit of cleanup, and it showed, so up there it moved down, but then it started to go up, and it's the best since June 2018, and it's still going up. I actually don't want it to go much higher because it starts to be too perfect, and that's not a good sign. But we managed a 43% improvement of delivery on time and meeting the deadlines since January 2019. So the takeaways: use the aging work chart and believe in Little's law, but in a very simple manner. Just keep as few circles as possible, manage your WIP. Pull, as in Kanban, so start here and then go here and here and here and here, and not the other way around. So start finishing and not start, don't start things, start finishing first. And then just don't let them go up, and make sure that they don't go too high. And that's about it. So thank you.